2, 3. Can I get the mic? Hello? Check, check, 1, 2. I also just want to throw out there for discussion and debate. We've talked a lot about anthropomorphism, which happens to be a thing I've worked on a lot ever since grad school. We cannot help but to breathe life and to see humanness in things, and so it's just the thing that happens. That is human psychology. But I think there's other models that we could use, including pets, horses, dogs. There's other interaction models that I think could be useful for thinking about how people work with these machines.
All right. Great. So to follow up on that, I'm Sonia from Georgia Tech. I'm also a roboticist, and I work on robots that help people in the home and make their lives hopefully better. And similar to Layla, I believe that robots don't really have to look like us to be useful. These are the types of robots I've used for the last 20 years. But more recently, I've made a little bit of a shift, and I would say that robots not only don't have to look like us, but sometimes they don't look like robots at all. And so for the last 3 years, I've been working with a team of other researchers at universities and 2 hospitals to develop smart home technologies. And this is a home that can tell when I've opened a door or the refrigerator, when I turn on the stove or the TV, or when I move around the house. And so it can sense, but it can also actuate. It can talk to me or display things on a display, on an app. And so this is really like being inside of a robot. In many, many ways, this is exactly the same technology in a very, very different embodied form. And similar to Door, one of the reasons we're studying this is to enable older adults to live independently as long as possible in their own homes, to make this technology affordable and more intelligent and assist them with independent life. What this technology does really depends on who you are. I'm not going to go into all of the details. It provides reminders. It helps older adults progress through complex tasks where they're starting to already forget some of the steps or remember to do them, as happens with cognitive decline. We also work closely with caregivers, care partners, friends, neighbors, sons and daughters who may or may not be living inside the home, to do things like give peace of mind when they're out of the house, provide alerts of what's going on, if someone's at risk of wandering or is not getting up in the morning or whatever it is. And we also work closely with clinicians. That's not our central focus, but we do work on capturing health trends and potentially early diagnosis as well. So it's a really exciting space, not particularly unusual for embodied AI, but really, really relevant and important. And it would seem like with the kind of state of machine learning today that we could just throw machine learning at this problem and get a solution. Of course, it should be easy to figure out when someone should get a reminder. But the problem is that every home is completely unique, not only in terms of layout and things that are in there, but also in terms of the people inside and what they want, how they behave. You know, our clinicians really want to know, did the older adult eat today? Because forgetting to eat is one of the major, major issues with mild cognitive impairment and dementia. I honestly can't tell. If you like to eat in front of the TV, I can't tell if you're just watching TV or just having it and chewing at the same time. Our sensors, they're very privacy preserving, are not giving us those insights. And so this can be quite a challenging problem. So this is the background I'm coming from. Physical robots, embodied AI, all kinds of different applications with humans. And given the conversation we've had for the last 2 days, I want to share just 4 insights that I think are relevant to everything we've talked about. So the first is very unsurprising. Users have different needs and wants. And also, like going further, it's sometimes impossible for us to anticipate what those are. Sometimes people say, well, just ask. Can't you just ask what they need? And the reality is because none of us could have foreseen, if you were around in the 80s, for example, what cell phones would be like today. Right? That you'd literally have a computer in your pocket. So it didn't make sense to say, well, what would you do with a cell phone? I don't know. I don't know that technology. It's the same problem. You can't ask what people would do with a technology they don't have. I'll show 2 quick examples. We've been surveying people about what they want robots to do for many decades. We seemingly get answers like, do my laundry, put away my groceries. When we get robots in front of our older adult population today, we actually show them these robots. Guess what? I get very, very low agreement on what they want those robots to do. So in terms of like very far down on the scale. Yes, please put away my groceries. No, definitely don't touch my groceries. I don't want to know, like, I don't want you to put them somewhere and I won't know where they are, right? So a huge spectrum. I think it'll narrow, but it's just so hard to develop a technology when users themselves are having a hard time telling you what they want. And I'll use one other example about anticipating user needs. This is one familiar to many of the roboticists in the room. This is Henry Evans, who suffered a stroke at 40 and is quadriplegic, and he is very actively engaged with the assistive robotics community, robot autonomous community, to help prototype and assist in design of a lot of these robotic systems. So this is an image from him testing out the brand new stretch robot when it recently had come out. And, you know, the engineering team sitting there watching what he's going to do. Is he going to go get water? Is he going to brush his hair? All these tasks he's done before. But what does he do? He goes and gets a flower, and he takes it to his wife. That's not one of the pre-coded capabilities of the robot. No one on the engineering team thought that, you know what we should pre-code is this capability, right? But that's so important to him. Now, the technology he needs in order to make this happen is incredibly custom and incredibly personalized to him, but it's empowering. It empowers him in a way that gives him agency and autonomy over this system to really make it his own. So this brings me to this second point, which is that in order, because we can't anticipate all these needs, we should involve users in the design and actual prototyping process from day one. And when we do so, and especially when we don't do so, prepare to be surprised. Okay? I'll show one really small example from our own work. So we envision a future in which robots are proactive. They ask for help, or maybe they're delivering packages and aren't sure where to go, or maybe they want to ask about your day and how you're feeling. So they're basically interrupting. And as we started to develop these robots, we felt like they were interrupting a lot. And so we asked two questions. Can we develop robots that can avoid interrupting? And if so, at least in a work setting, can people be more productive because they're not being interrupted? And so first answer is yes. Turns out from just visual data, we can tell if someone's pretty busy. And we can drop interruptions from 40% to 5% in a particular context. This is great, fantastic. I could take an hour of production work, show less interruptibility, so clearly this will transfer into more productivity for people, right? Nope. Surprise, it didn't. So we're digging further and further, and what eventually we find is that it does not translate into actual productivity, but people hate the robot that interrupts. Right? So it translates into adoption. That people actually like the robot that is considerate and is better behaved. The reason you don't see a difference in productivity, turns out, humans, we never put any time pressure. We didn't tell them how many tasks to complete or how fast to do them, but they felt like they were behind. The interruption put them behind, and every single one of our users, after the interruption, started doing their tasks faster in order to catch up. So they felt this burden and stress, even though we weren't like sitting there with a stopwatch at all, right? And so there's all these unconscious, subconscious effects of these interactions that we need to account for. 3, we've talked a lot about LLMs, and not everyone here works with LLMs, and I just wanted to touch on why LLMs are so powerful in this context, and talk about the semantic abstraction that they provide that enables us to actually deal with a lot of this diversity that I'm talking about. It's not, there's solutions here. Though I will say with the caveat that, at least today, models that we fine-tune to a particular person remain more efficient, more effective than the default LLM model that the difference is converging. The reason LLMs are so powerful in this context is because language itself is a type of semantic abstraction that is something we've developed as a species to help us cope with the diversity of the world. If you followed computer vision research, there was a huge revolution when we had semantic segmentation, when we stopped thinking about thousands and thousands of pixels, individual pixels in an image, and started thinking about semantic regions. Floor, table, wall, right? Now this is much easier to reason about, thinking about it at a higher level. Words like, well, this room is now organized. I've organized your house. That's an incredibly abstract concept that language captures really well. In the context of our smart home work with older adults, I'll give one example, something we now can do in this past year that we couldn't do before. And that's human activity recognition in brand new homes. Turns out, this is a really hard problem because every home is different. It's very hard to field in a new home. You usually have to collect more training data, fine-tune, and so on. That's impractical. But if you take LLMs, if you take sensor data, abstract it up through the use of language, and then bring it back down into a numerical construct using machine learning, you can not only gain the same performance benefits, but also apply this to new homes without any fine-tuning. Huge result for our field, because we could not do this before LLMs. And just to touch on one last one, which is so, so important, interpretability. We haven't talked, I think, enough about that. There's a big focus on, we have AI making decisions. It's important that we understand why the AI is making decisions, a particular decision. But overtrust is a serious risk, and I just want to give one example. So when an AI explains why it did something or chose an outcome, a good explanation should be relatively faithful to how the model works, understandable to the user, and useful for the user's end goals. Okay? What does relatively faithful mean here? So when you have an LLM providing explanations, one of the challenges is because LLMs are trained on all this human text, the explanation that it generates about itself or another model is inherently plausible in the sense that it pairs words in the right order based on orders it's seen before that make it sound realistic. What happens if that explanation is plausible but not faithful to the model? I'll give an example from medical diagnosis. AIs that help doctors make clinical decisions, which are fielded today. This is the work of Hima Lakkaraju from Harvard. I wish it was my work. This is hers. What they find, so they work with actual medical doctors in epilepsy. They take a doctor and they measure their baseline accuracy in diagnosing epilepsy before any intervention. Turns out if you give an AI that says yes, no on a diagnosis, the doctor's, that's all it says, yes, no. The doctor's accuracy goes up. Even if the model is sometimes wrong, accuracy goes up. You give that same model with the same accuracy, with the same yes, no, but now coupled with a plausible explanation, the LLM explanation of why, look what happens. We are now below what doctors could have done without AI. We've hurt medical performance. Why? Because when it's wrong, it sounds so convincing, it's talking them out of the diagnosis they would have otherwise made that would have been correct. So when it's wrong, it's convincing the doctors of the other way. This is not out yet. I saw her present this 3 weeks ago. It's about to go public in the news soon. But I wanted to share this result because I think it makes a big difference about the use of AI and explainability. So with that, I talked about 4 different things here. But the takeaway I want you to remember is that AI is changing so rapidly right now, like so rapidly. We've talked about that. It's really critical that we step back, take time to understand the impact that this technology really has on the users and how they interface not only with the technology itself, but with each other. Thank you.